Hello class, welcome to Algebra Lesson 1-1, which is all about operations on real numbers. By the end of this lesson, you should be able to reason about operations on real numbers. So example 1, let's understand what a set and a subset is. So if we look at this example, in the set of numbers from 1 to 10, so that means all of the numbers between 1 and 10. In this case, we are just talking about integers, whole numbers, so none of the decimals. So A, right here, is our set of numbers 1 from 10. Which are elements, so vocab word, each of these numbers is considered an element in the set. So the whole thing here is a set, and then each individual number is an element, okay? So a set is the whole thing, an element is each individual thing. All right, so in the set of numbers from 1 to 10, which elements are in both the subset of even numbers and the subset of multiples of 5? So a subset is when you take the set and you pull out a smaller group. So the subset of even numbers would be 2, 4, 6, 8, and 10. The subset that is the multiples of 5 out of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, the only ones that are multiples of 5 would be 5 and 10. Okay? So we have our set. Set A is all of the numbers, right? Set B is a subset of set A. It's a smaller version of set A. And C is a subset of set A. It's a smaller version of set A. And we want to know which elements are in both subsets. So 2 does not appear in both, 4 does not appear in both, 6 does not appear in both, 8 does not appear in both. But if I look, 10 appears in both. Or a faster way would have been to start with the smaller set, be like, there's no 5 in the other one, but look, there's a 10, and I would have been done. So all this question was asking was which number appears in both sets, and the answer would be the number 10. So that means it is your turn. Question 1 for you. Which numbers in set A, so I've listed set A for you, are elements in both the subset of odd numbers? So what you should do is you should make a subset B of the odd numbers, and then the subset of multiples of 3. So then make a third set of multiples of 3 and see what numbers overlap between those two sets. Good luck. All right, hopefully you said the answer was both 3 and 9. You saw that 3 is an odd number and it's a multiple of 3. 9 is an odd number and it's a multiple of 3. So you should have listed both of those answers. Now, example 2, compare and order real numbers. Jim is playing a math game where he needs to put a set of 3 cards in numerical order from least to greatest, okay? Big, long way of saying we're ordering from smallest to biggest or least to greatest, okay? His cards show the following values: 40 elevenths, square root of 324 over 36, and the square root of 10. Now, if you're looking at these and you're like, I have no idea what these numbers equal, I would say you guys are most comfortable with decimals. At this point, you guys are probably the most comfortable with that. So what I'm okay with you doing is grabbing a calculator and saying, what is 40 divided by 11? That is about 3.64. Then, in your calculator, type in, what is the square root of 324 divided by 36? When you do that, you should get 3. And yes, even though I'm writing the answer on the board, you should be testing this to make sure you're using your calculator correctly. Because if you're not using your calculator correctly, you're not going to pass the test if this is how you're doing these problems, right? So test it out now when the answers don't matter. That way you can ask me questions if you need help. And the square root of 10 is 3.16. So if I want to order these from least to greatest, my smallest number would be the square root of 324 over 36. The next smallest number would be the square root of 10, and the largest number would be 40 over 11. Okay, so when you do this next question on your own, I suggest maybe checking out some decimals. Good luck. All right, for this problem, hopefully you ended up with the smallest being 6 over 25, or 6/25, the second smallest being 0.25, and the biggest, or the, I guess, third smallest, square root of 1/9. If you have questions about that, please be sure to ask for some help. All right, example 3, operations with rational numbers. So let's quickly review. A rational number is, any number that can be written as a fraction or decimal. And this includes repeating decimals. Irrational means that a number is non-repeating and never ending. So that number goes on and on forever and ever, just like how you guys feel about my math videos sometimes, okay? So irrational relates to Miss Johnson's math videos. They feel like they're never gonna end, okay? So, rational, any number that can be written as a fraction or decimal, includes repeating decimals. Irrational is a non-repeating, never-ending decimal. I'm gonna erase this, so if you wanna write that down, you should write that down before it disappears off the screen, or rewind the video and copy it down. Because we are gonna look at letter A. Is the sum of two rational numbers always a rational number? So let's think about that. Two rational numbers. We said any rational number can be written as a fraction, right? So what if I did like 1/8 plus 2/8? Okay, so that's two rational numbers, right? They're two fractions. Well, the sum of those would be 3/8. Okay, so 1/8 plus 2/8 is 3/8, and that is a rational number, right? Because it's another fraction. What if we did like 0.45 plus 0.3? Those are both rational numbers. They're decimals that end, right? And it would be 0.75, which is another rational number. So the sum of two rational numbers, I'm not going to get into a big, long explanation about this, but two rational numbers, when you add them together, will always be rational, okay? The sum of two rational numbers is always rational. Then letter B, what about the product of two rational numbers? So let's try the same thing. If I did 1/8 times 2/8, if I multiply those, I would have 2/64 or 1/32. Well, that's still a fraction, so that is still a rational number. And I could do 0.45 times 0.3, and I end up with 0.135. Another decimal that ends, right? So the product of two rational numbers, again, I could go into a big, long explanation, but this is a point where I'm telling you to trust me. I'm not going to expect you guys to know the next level of thinking with this, okay? So the product of two rational numbers is always a rational number. Question number 3. This one's for you. Is the quotient of two rational numbers always a rational number? Explain. Good luck. Hopefully the answer you said is yes. I wrote out one example, right? So the quotient means we're dividing. So what if I divided two fractions? Because we've already said that fractions are rational. So 1/3 divided by 1/4. Well, if I'm dividing fractions, that is the same as multiplying fractions, or multiplying by the reciprocal, right? Which means that I'm multiplying two rational numbers, which on the last slide we said is rational. So your answer would be yes. All right, example 4. Is the sum of a rational number and an irrational number rational or irrational? So let's think about that. This is sometimes easier with some decimals. So I'm going to just choose 0.25. And why don't we say plus pi? Okay, so I'm going to add pi to this, right? Plus 3.14159265 These numbers are going to go on forever and ever, right? So just because I add 3.14 or add 0.25 to it, these numbers over here after this 5 are just going to stay the same and continue on forever and ever. They're not going to repeat, and they are not going to end. So when you add a rational number to an irrational number, it's still going to be irrational because the irrational number is going to go on forever and ever beyond the end of that rational number. So then letter B is the product of a rational number, so let's try that, and an irrational number, rational or irrational. So if I did 1/4 times, let's see, thus we'll do pi again because we like pi. Okay, so if I did 1/4 times pi, I'm still going to have a big long decimal that continues on and on and on, and it keeps going forever and ever because that's how pi works. So when you multiply a rational and an irrational number, you end up with an irrational number, okay? So that is important for you to remember. The next question is, for you, is the difference of a rational number and an irrational number always irrational? Good luck. Hopefully you answered with yes, and you may not have an idea of why you said yes. You might be like getting really excited in front of your laptop because you just guessed yes and you happen to be right. But let me tell you the rationale behind why the answer is yes. So on the last, or a couple slides ago, we talked about how, or on the last slide, we talked about how the sum of a rational and an irrational number was irrational. Now, if we think about difference is the same as sum, except one of your numbers is negative, right? So you can think of subtracting as adding a negative number. So really, difference, this operates the same way as a sum. When you add a rational number, or when you subtract a rational number and irrational number, you're going to have an irrational number. You're going to have a number that goes on forever and ever, okay? And this last slide, the concept summary, summarizes everything in one nice slide for you. So if you're someone that struggles to take notes but likes to reference things, if you take a screenshot of this slide will be your best friend for this section. It summarizes everything you need to know. I will tell you that if you're looking at this slide, this bottom portion here is the stuff I didn't cover in this video. That doesn't mean that you can't look at it and you can't learn about it. That is the next level for those of you that want to go to that next level. And we can certainly talk about that one-on-one, but I'm not going to test you on this kind of stuff. I will test you on this stuff up here. That's what we talked about in today's video. If you have any questions at all, please be sure to reach out for some help, and I'd be more than happy to assist you. Have a great day.
Expressions. Before we start going over some examples, let's talk about some of our terms here. So first, what is an algebraic expression? Now you should remember what a numerical expression is, because we've talked about that before. An expression that includes numbers and operations. That's basically it. There's no equal sign. Remember, expressions have no equal sign. That's equations. Okay. An algebraic expression is different than a numerical because it includes variables. So the definition, and you should write this down, an expression that contains numbers, operations. So if it just has those, then it's just a numerical expression. But if it also has one or more variables, then all of a sudden we're talking about an algebraic expression. So some examples: x divided by 7. We've got a variable, we've got an operation, we've got a number. Same thing here, 3x plus 4, xy. You don't see the operation, but when they're next to each other, that means multiplication, so there is an operation. So those are all examples of an algebraic expression. Some that aren't. If you've got something like 3 plus 7, that's not an algebraic expression because there is no variable. right? That would be just a numerical expression. Same thing if you got 3x plus 4 equals 10. That also is not. Even though it has variable operations, it's got numbers, it has an equal sign, which means this is actually an equation, not an expression at all. Okay. So make sure you understand what an algebraic expression is and what it includes. Let's talk about some more vocabulary words. Here is an algebraic expression, 5p plus 4. We have operations. We've got addition, 5p, that means 5 times p, so we have multiplication. We have numbers, we have a variable, so it's an algebraic expression. Now, let's talk about the different parts of this algebraic expression. First are the terms, and the terms are just the parts of the expression. So in this case, we have two terms. We have 5p and we have 4. So if you had to write down and list what the terms were, you would write, well, 5p is a term and 4 is a term. Basically, you just take out the operations and you list just the parts of the expression. Okay. Next, the coefficient. And you can see that I kind of color coordinated here. A coefficient is the numerical factor of a term, right, one of the parts, that contains a variable. Well, the only term here that contains a variable is the 5p. The coefficient is the numerical factor. So it's the part of the term, it's the number, basically, part of the term. So in this case, in this expression, the coefficient here is 5. Okay. You can think of, well, it's just the number in front of the variable, okay, just which it is, right? Next, a variable. Well, what is a variable? A variable is just a symbol. Usually we write it as a letter, and oftentimes it's either X or Y because of the coordinate grid, right? You have the X-axis and the Y-axis, which is why oftentimes you see equations or expressions with X and Y. But it can be any letter you want. And it represents one or more numbers. It's called a variable because it can vary. In this expression, I can say, well, let's make p equal to 5. Or let's say p is equal to 3. Or p is equal to 1,000,000. Right? I can choose whatever I want for that p. That's why it's called a variable. It can vary. It can change. And so in this case, our variable, blue with the blue, our variable is p. Okay. And last but not least is the constant. Now, when you think of constant, things that are constant are things that don't change. Okay, that's something that's constant. Gravity is a constant. Gravity doesn't change unless you get out into space, right? So this constant, it's a term with no variable. So here, our only term with no variable was the 4. That 4, no matter what I make p, that 4 will always be 4. It's not going to change. It is a constant. So these are the different terms and things you should know about an algebraic expression. Okay. Let's do an example. Example 1, identify the terms, coefficients, and constants of this algebraic expression. First, let's start with the terms. Remember, those are the parts. And if you want to try this on your own, go for it. Go ahead and pause the video. The terms are the parts of this. So we kind of take the operations out. And the terms, well, we've got a term here and a term here. So the terms, you have 5x and you have 13. Next, the coefficients. Well, coefficients, we're only looking at the terms that have a variable. So coefficients, I'm not even going to bother with that 13. I'm just going to look at the 5x. And then remember, it's the numerical part of the term that has the variable. So out of this 5x, the coefficient is just the 5. And last but not least, the constants. Remember, that's something that doesn't change no matter what the variable is. So in this situation, the constant is at 13. Okay, it doesn't include anything next to a variable, right? That's the constant. It stays 13 no matter what. Okay. Here's some to try on your own. Example 2, simplify the expression. So I have 1.5 times h times h times h. So hopefully you notice right off the bat you have repeated multiplication, h times h times h. Well, we know a shortcut, something that we can simplify that into, and that's using exponents. I have h multiplied by itself 3 times, so that's the same as h cubed. And 1.5 times all of that, well, I can get rid of this multiplication symbol and just put them next to each other, right? That still means the same thing. So if I write 1.5 h cubed, it's exactly the same thing, just simplified, right? So that is what it would look like if you simplify that expression, 1.5 h cubed. And in this case, 1.5 would be your coefficient. Good. Here's some more to try on your own. Here's our last example. Evaluate 3x minus 14 when x equals 5. So now in this situation, they're telling us exactly what the variable is going to be equal to, and that's going to be 5. So my first step is to substitute. To evaluate, I'm trying to find the value, and in order to do that, I need to substitute that 5 in for x, because it's saying x is equal to 5. So what I'm going to do is I have 3. Now, a good habit to get into is when you substitute, use parentheses. All I'm doing is replacing that 5 for the x. I'm substituting it in. So 3 times 5, remember 3x, that means 3 times x. So I have 3 times 5. I still have the minus 14. And now it's just order of operations. I have multiplication and I have subtraction. Multiplication comes first. So 3 times 5 is 15. Minus the 14 is 1. And that is my final answer.